Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing the numericals of stationary waves. Let's start with them. Please take down the sum. What should be the tension applied to the wire? What should be the tension applied to the wire of length 2 meters and mass 5 grams if it has to vibrate with a frequency of 100 Hertz. If it has to vibrate with a frequency of 100 Hertz. Frequency is given by 1 upon 2L root of T by M. So in that case I can say N square is 1 upon 4L square T by M. Therefore I can say that T is 4N square L square M. Now remember, your mass has to be not just the mass of the wire, but it has to be mass per unit length, right? So I think you have all the values N, M and L. Yes, you should be able to get the answer. The answer for this should be 400 newtons. Next, take down next sum please. A flexible string of length 0.99 meters and mass 1 gram is stretched by a tension of T newtons. Is stretched by a tension of T newtons. The string vibrates in 3 segments. The string vibrates in 3 segments of frequency 500 Hertz. Find the tension on the string. Find the tension on the string. Now since the string is vibrating in 3 segments, it will be P times 1 upon 2L square root of T by M. Sorry. So therefore I can say N square is P square upon 4L square T upon M. Therefore I can say that T is nothing but 4N square L square M upon P square. Should be able to get the tension on the string. All the values are given to you. Answer should be 110 newtons. Next, take down next sum please. A flexible string of length 0.88 meters is stretched by a force of 55 newtons. 0.88 meters is stretched by a force of 55 newtons. The mass on the string is 1 gram. The mass of the string is 1 gram calculate the frequency of vibration. Calculate the frequency of vibration if the string vibrates. Calculate the frequency of vibration if the string vibrates in 5 segments. If the string vibrates, calculate the frequency of vibration if the string vibrates in 5 segments. Replica of the previous sum. I can say that n is equal to P upon 2L square root of T by M. Squaring both sides, I can say n square is P square upon 4L square T upon M. They've asked you to find out, what have they asked you to find out? Find the frequency. I can straight away get the frequency, I didn't need to square it. They've asked you frequency. I have all the values, I can just directly substitute and get the answer. The answer for this should be 625 Hertz. Next, take on next one please. A steel wire of diameter, a steel wire of diameter a steel wire of diameter 1 millimeter and length 25 centimeters and length 25 centimeters is stretched under a tension of 31.42 newtons. Is stretched under a tension of 31.42 newtons. If the density of steel is 8000 kgs per meter cube, find the linear density of the wire. Find the linear density of the wire second, the velocity of the transverse wave on the wire. The velocity of the transverse wave on the wire. And third, the frequency of the third overtone. The frequency of the third overtone. The frequency of the third overtone. Now I can say density is nothing but mass upon volume. Therefore I can say mass of the wire will be density into volume. Wire is in the form of a cylinder. Therefore I can say density volume is nothing but pi r square L, right? So I know R, I know L, so I should get the volume and I have the density, so I'll come to know mass. Once I have this, then I can say that linear density or linear density, that is M, is M upon L. M is nothing but rho pi r square L upon L. So this is going to be rho pi r square. That will be my linear density. That's my first part of the question. The second part of the question they've asked me is find the velocity of the transverse wave. Now, velocity of the transverse wave, V, is nothing but square root of T by M. Velocity of the transverse wave is nothing but square root of T by M. You have the tension on the string, yes. Linear density you found out, so you should be able to get this. And the last part of the question is fundamental frequency. First let's find out the fundamental frequency. 1 upon 2L square root of T by M. So that will give me the fundamental frequency. They've asked me third overtone. Third overtone will be 4 times the fundamental frequency. So that will be equal to 4N. Right? So you should be able to get the answers for this. Answer should be linear density should be equal to 6.284 into 10 raised to minus 3 kgs per meter. Velocity of the transverse wave is 70.71 meters per second. Fundamental frequency is 141.4 Hertz, and third overtone will be 4 times this. Multiply and you will get your answer. Next, take down next one please. Two wires of the same material, have same diameter. Two wires of the same material have the same diameter and their lengths are in the ratio of 1:3. Their lengths are in the ratio of 1:3. And their tensions are in the ratio of 1:4. Compare their fundamental frequencies. Compare their fundamental frequencies. Compare their fundamental frequencies. Now we know that frequency is 1 upon 2L square root of T by M. Therefore I can say that frequency is directly proportional to square root of T and inversely proportional to the length. Hence I could say that N1 upon N2 is square root of T1 upon T2 into L2 upon L1. You know T1 upon T2, you know L1 upon L2, so you should be able to get L2 upon L1. You will get the answer for this. The answer for this should be 3:2. Next, take down next one please. Two wires of the same material, have their lengths. Two wires of the same material have their lengths in the ratio of 2:1. Have their length in the ratio of 2:1. Their diameter in the ratio of 3:1, and tension in the ratio of 1:4. Find the ratio of their fundamental frequency. Find the ratio of their fundamental frequency. N is equal to 1 upon 2L square root of T by M. Mass, this is linear density, so this is going to be 1 upon 2L square root of T. Linear density is nothing but mass per unit length, so that will be M upon L. Now this can be written as fundamental frequency N is 1 upon 2L square root of TL upon mass. Mass is nothing but density into volume, right? Now, this can be written as 1 upon 2L square root of TL density, volume. The wire is in the form of the cylinder, so that is going to be pi r square L, but radius is nothing but diameter upon 2, so this is pi diameter upon 2 the whole square into L. L and L gets cancelled, so in that case you will get this as 1 upon 2L square root of 4T upon rho pi d square. Hence I can say that the frequency is directly proportional. Hence I can say that the frequency N is directly proportional to square root of T and is inversely proportional to L into square root of D square, which can be written as D. You have square root of D square, which can be written as D. Therefore, I can say that N1 upon N2 is equal to square root of T1 upon T2 into L2 upon L1 into D2 upon D1. All the values are given to you. You should be able to substitute and get the answer. The answer for this sum should be just write the answer for this. The answer for this sum should be nothing but 1 upon 12. Answer is 1:12. Which part here? This M.
N here so that we can get density and volume. Then what about the N here then? Why do we convert it into N again?
No, we haven't. We always have that N. Next, take on next sum please. Two wires of the same material. Two wires of the same material when sounded together give 4 beats per second. Give 4 beats per second. The diameters are in the ratio. The diameters are in the ratio of 3:4. Diameters are in the ratio of 3:4, and the tensions are in the ratio of 9:16. The vibrating lengths are 0.59 meters and 0.6 meter. Find the frequency of vibration for each wire. Find the frequency of vibration for each wire. Find the frequency of vibration for each wire. N is equal to 1 upon 2L square root of T by M. So I can therefore say that N is 1 upon 2L square root of T, as it is M is nothing but mass per unit length. So this is going to be M upon L. So N is 1 upon 2L square root of TL. Mass is density into volume, which can be written as 1 upon 2L square root of TL density pi r square L. L and L gets cancelled, therefore I can say N is directly proportional to square root of T and inversely proportional to square root of length and diameter. Hence I can say that N1 upon N2 is square root of T1 upon T2 into L2 upon L1 into D2 upon D1, right? So I'll get the ratio of N1 is to N2. Now when you solve this, you will get this answer as, 60 N2 is equal to 59 N1, right? Therefore I can say that N1 upon N2 is nothing but 60 upon 59. Hence I can say that N1 is greater than N2, right? If N1 is greater than N2, then I can say that beats are given to you as, it gives you 4 beats per second, right? Beats is always the larger frequency minus the smaller frequency, right? So this is going to be N1 minus N2 is 4. Therefore I can say that N1 is N2 plus 4. Substitute this value in the above equation, so I will get that N2 plus 4 upon N2 is 60 upon 59. There is only one unknown in this equation, which is N2. So you should be able to get the value of N2 and then subsequently substitute here, you will get the value of N1. The answer for this sum should be N1 is going to be equal to 240 Hertz and N2 is 236 Hertz. Next, take down next some beats. An addition of 24 kgs to the tension, has changed the frequency to 3 times the original frequency. What is the original frequency? Sorry, what's the original tension, not frequency, what's the original tension? N is equal to 1 upon 2L square root of T by M. Therefore, I can say N is directly proportional to square root of T. Therefore, I could say that N1 upon N2 is nothing but square root of T1 upon T2. Fine, do we get this thing clear? Now, once you have this, I should therefore be able to say that N1 square upon N2 square is equal to T1 upon T2. You have N1 can be as it is, N2 can be written as 3 times N1, the whole square is T1 as it is. T2 can be written as T1 plus 24. When you solve this, you will get the value of T1. You should get this answer as, you will get T1 as 3 kg weight. So therefore T1 can be written as 3 into 9.8. So that will give you 29.4 newtons. So the tension on the string, original tension on the string should be 29.4 newtons, right? Okay, we'll stop this here for the day. Thank you very much.